So I'm back to talk about domain and range of our functions. You've seen this talked about with other functions. Domain is the x values that we can plug in. So a little summary here. Domain is the x values. What can I plug in that works? Okay, we don't want imaginary numbers. We don't want to divide by 0. We don't want any issues. So what are the domain? What x values can I plug in? My grammar there was not super good. Don't judge me. Okay, domain, x values. The range is after we plug in those x values, what are the y values that our graph can equal? The cool thing is we've talked about our key features. The domain relates with our vertical asymptote, and our range will relate to our horizontal asymptotes. We've talked about it. Sometimes we can cross a horizontal asymptote, which could give us issues, and sometimes we might have a hole in a graph, which is going to cause even more issues. So I'm going to keep these examples very safe, so it is very clear where those horizontal asymptotes are, so it's easier to recognize the domain and range. But future reference, that can change. It won't for us, but it can in the future, and it just gets a little bit more complex. But the idea is still the same. So I'm going to show you two different ways to kind of write the domain and range, and then I'll explain what it's going to look like on the quiz. So with our first example over here, so our denominator here, we can see that we're going to have a vertical asymptote at x equals -2, which we have here, right? Okay, and then my horizontal asymptote, since my equation is equal, x over x, we have a horizontal asymptote at 1. So for my domain, I can't plug in 2 because that's going to make me divide by 0. And then our function will never equal 1, that horizontal asymptote. We'll never cross 1 with this example. So the way that I'm going to write this for my domain, I'm going to show you two different methods. This first one is how it's going to look on the quiz. This is called set builder notation. The way that we write this is going to be the same for everything. The only thing that changes is that vertical asymptote value. So it makes us look kind of cool when we write this. It says x is an element of all real numbers, meaning we can use every single number for x. But, this line kind of just means but, can't. We can't use -2. So x is every number, but it cannot be -2. On the quiz, all you have to do is fill in this blank. X is all reals, but x cannot equal, and tell me what x can't equal, right? So that's set builder notation. And then we have what is called interval notation. And it's just telling me we're going to show what numbers it can be, what it can't be. So interval notation, I'm going to start at -infinity and I'm going to end at -2. So I can use every number between -infinity and -2, but I can't use -2. That's why we have a parenthesis. And then I'm going to go from -2 to infinity. So that's the way to say I'm using every single number except -2. Set builder, interval notation. They both have their purposes. They both look kind of cool. But on our quiz, we're going to see the set builder. Again, all you have to do is fill in that blank. So that's the domain of my graph, and that's referring to my vertical asymptote. Now let's talk about the range. So the range is our y values. Domain is x, range is y. So the process, it's going to look the exact same, but instead of x, this is going to say y is an element of all reals. It's every number out there, except y cannot equal 1. We're going to get closer and closer to 1, but it's never going to equal 1. And in interval notation, that's -infinity to 1 and 1 to infinity. Okay, again, with the quiz, you're just going to have to fill in that blank right there. Y is an element of all real, but y cannot equal. That's going to be supplied. Just fill in the box. Okay. Example 1. Second example real quick. We have this graph. If we were to look real quick we can see our vertical asymptote is at x equals 4. Then if we look for the horizontal asymptote, it is equal x over 2x, so that's going to reduce to 1 over 2. From there, we can translate that into our domain and range. So my domain, x is an element of all real numbers, but x cannot equal 4. If I plug in 4, I'm dividing by 0. That's a problem. That also looks like negative infinity to 4 and 4 to infinity. My range, using my horizontal asymptote and my y values. Y is an element of all reals, but y cannot equal 1/2. And using interval, that's negative infinity to 1/2 and 1/2 to infinity. Okay, I think on the practice sheet, I've made a little bit more complex. I've used a couple vertical asymptotes. Works the exact same way. If you've got questions, ask away.